Hi, my name is Tim Fairfield. This video demonstrates how measurement throughput can be increased by the disaggregation of test signal acquisition and signal analysis by running several of these processes in parallel. As a practical example, we measured and analyzed a 200G transceiver consisting of 26 gigabaud PAM4 signals from 4 transmitter channels. Looking at the traditional approach, the acquisition and analysis happens on the same hardware. Therefore, acquisition and analysis have to take place sequentially. The initial experiment uses a 4-channel DCA-M connected to a 2.8 GHz Intel i7 PC running FlexDCA software. The first acquisition starts and the waveform for each of the 4 channels is displayed. Then the first analysis begins. Next, a second acquisition is triggered, followed by the second analysis. The acquisition and analysis steps each take 9.5 seconds. These steps are repeated a number of times. 10 acquisition and analysis cycles take a total of 95 seconds to complete. Using the timing analysis tool, we can see the timing diagram for 10 measurements. Now let's look at the disaggregation approach. Here, the acquisition and analysis tasks run on different computers. If the waveform analysis takes longer than the acquisition, the analysis is distributed to run on several physical or virtual machines in parallel. In the second experiment, the acquisition is set up exactly the same as in experiment 1. The signals are captured by the 4-channel DCA-M and are connected to the same PC. In contrast to experiment 1, where the signals were processed on the same PC, the captured waveforms are now sent to the 4 other PCs for analysis. For both experiments, we are using the KS400A PathWave test automation platform for instrument control and test flow. For the analysis, we were using the new N1094BS1A PAM4 measurement SDK, which runs on the 4 additional physical or virtual machines. The N1094BS1A calculates key PAM4 parameters like TDECQ, outer OMA, optical extinction ratio, eye width, linearity, and skew. In the disaggregation experiment, it starts with a new waveform acquisition. The waveform data is uploaded and the first analysis is started. Immediately after the first acquisition, the second transmission is started. Most notably, the subsequent analysis and acquisitions are running in parallel, and so on. Again, let's have a look at the timing diagram. On the bottom line, you will see the waveform acquisitions and the data transmission. On the lines above, you see the analysis processes on the 4 physical machines. The red numbers on the left show that the DCA acquisition hardware is utilized almost 100% of the time. The utilization of the analysis machines range from 70 to 87%, depending on the processor type. Finally, comparing both experiments shows that the disaggregation and parallel processing improve the measurement time by a factor of 2 and reduce the test time by half over the traditional approach. In addition, the DCA acquisition hardware utilization is now increased to almost 100%. The analysis computers used in this experiment are physical PCs connected to the DCA control PC via the local network. This architecture can also be implemented with cloud-based virtual PCs. In this case, the latency impact of data transmission can be offset by enabling more cloud PCs until maximum DCA utilization is achieved. Open your browser. Give it Keysight.com. Find N1094BS1A to learn more.